now. Oh my god, always streaming now, guys. Let me test. First time I did this. Hello. Pretty fun. I have desktop audio. Wait, what is this? This is a mic aux. Can y'all hear me? How do I know if this thing is working? Are we live right now? Desktop audio. Desktop audio. There's mic, a screen capture. Okay, there's a mic, there's a screen capture, and there's my video, right? I don't see my video in here. Oh, this is audio. Oh, this is audio mixer. Oh, so there's a Mac screen capture audio, and there's a duration of scene transitions. I don't think I need any of this. Okay, I think we're good. Let's start the stream. So hello guys, today we'll be doing leetcode contest. This is the contest 364, but this is the first time that I do this. The purpose of this stream is to show you how bad I am as a coder. So let's start with the first problem. Okay. You're given a binary string S that contains at least one, and you have to rearrange the bits in such a way that the resulting binary number is the maximum odd binary number that can be created from this combination. Oh, the maximum odd. So you want all the one in the front, and you want to leave one at the end. Okay, that makes sense. So you have a binary string of 0 and 1, and you want to rearrange these 1s and 0s. Okay, so the input is a string, and they want you to output the final string. That should be easy. So do we have to return a string? Okay, so first I'm gonna grab the length of the string, and I'm gonna count all the ones in the string. So I'm gonna start like this for C in S. If C equal to 1, then I'm gonna count ones plus equal 1, and then my answer will be this. Actually, let's do this. Let's start all of my answer as this, and then I want at least one. Okay, so I want to make my answer, the last one, as 1, right, and for I in range of 1s minus 1, I want to do ans of I equal to 1. So maybe I want this to be string of 0 then. Okay, and then I'll return this join ans. Okay, that should be easy. Okay, one down. Number 2, beautiful tower 1. So we have 8,000 total accepted submissions for this one. You're given a 0 index array of max heights of n integers. Hold on guys, I wonder if I should stop the stream and check if my stream is working, because if it is not, then I'll be just wasting a bunch of time. I'll worry about that later. Let's finish the second problem. Max height, you're tasked with building n towers with the coordinate in the coordinate line. The ith tower is built at the coordinate I and has a height of heights I. A configuration of tower is beautiful if the following conditions hold. One is smaller or equal to height, smaller and equal to max height. What does that even mean? Height is a mountain array. Array height is a mountain if there exists an index I such that height j minus 1 is smaller or equal to height of j for all j smaller than I if there exists an index. Okay. For all I k from I to n minus 1. This is smaller than this? Wait, hold on. K plus 1 is smaller than k. So it goes like this. Okay. If there's such an index, return the maximum possible sum of heights of a beautiful configuration of towers. But what makes it beautiful? Heights of I smaller or max heights of I? What the fuck is this? Max height of I? Okay, let's see an example, guys. 5, 3, 4, 4, 4, L plus 13, one beautiful configuration with a maximum sum is heights 5, 3, 3, 1, 1. This configuration is beautiful since 1 is smaller than heights of I is smaller. What? Height is a mountain peak of I equal to 0. That there exists no other beautiful configuration with a sum of heights greater than 13. Huh? What is this? Towers, the I tower, and has a height. I don't understand the question. It's so fucking stupid. Height of heights at I. One is smaller. Okay. So that you're given a max height and you want to have it asks you return the maximum sum of height. I see. So you want us to find a height configuration. I hear mountain array. Oh, I see. Yeah, you want to find a mountain array. Oh, you want to find a mountain array. Oh. Gotcha. I understand now. So you want to find the maximum. So for the second example, you probably want to make 9. Okay, so you have to cut these things down. Okay. We get this one, and you have to make sure this is the largest. Max height 10 to the third. Okay, so length is 1,000, And how do we do this? Because I can see that we can loop through all the array and pick a pivot, and then from the pivot you just need to find the result. So the complexity is n squared, but I feel like this is not an optimal solution for a second problem. You can pick n pivots, and for each pivot you find the sum. But how do we do this? How do you know which one will yield the maximum result? Let me think. 5, 6, okay. Once you go, so if you pick a pivot at 9, you know that you have to sacrifice a certain amount for the sum. So which is, you go from that pivot, you go to the left and you go to the right, and then you kind of accumulate that. You can calculate how much you're losing. If you have a pivot. How do I do this? Yeah, you can calculate how much you're losing if you pick a pivot from index I. So let's say you start from 6, you go to 5, and you know that you'll lose 1 unit if you pick a pivot at 5, and then you jump to 3, and you see that 3 is smaller. If it is larger, right? If it is larger, then it's totally fine. You don't have to lose anything. But if you go to like a smaller one, and then you check, right? So you check. So 3, you know that there's some numbers that need to be cut off. So let's say you go to 2, has to make up 7 units. 7 units for this. I'm thinking. I know this problem's probably using a stack, because it looks like a stack problem to me. Looks like a stack problem to me, so that you can solve this in O of n, right? Right? But how do we solve this using a stack? So freaking cold in here, I cannot think. 2, 6, let me think. So it's 2, 6, 5. Freak. 9, 2. So 9, you have to sacrifice 7 units. But 3, you know that how many units you have to sacrifice. But 3 kind of represents more numbers than that, right? More numbers than that. This is the smallest. We probably want to just store the smallest. So let's say if it is 2, then you store the smallest. You don't care about the numbers. Yeah. You just want to store the smallest. If it is 7, then you only care about keep like a stack of increasing values. And you get this value, you pop the larger one out because they're the one that need to be compensated. They're the one that need to be cut off. So I know how much we need to cut off right there, right? So like let's say it's a 9. It needs to be removed, right? Keep like an increasing stack like this. Yeah, that totally makes sense. If it's larger, oh my god, I cannot think, guys. It's too cold to continue. I might have to stop the stream. It's kind of stupid, but we'll see you in the next stream. Okay, how do I stop this? Exit, stop streaming. You will not be able to reconnect your